Okay, so this is gonna be a first episode in a series explaining Redox, the Redox unit of Chemistry 30, the Alberta program. And for the first episode, I'm gonna intro what Redox is. So Redox is what is equal to reduction and oxidation reactions. So what exactly is a reduction oxidation reaction? What does that even mean? It's just a reduction or oxidation reaction refers to a transfer or the apparent transfer of electrons in a chemical reaction. So how would that look like? It would be as if, for example, the oxidation of iron to rust. That would be a reduction reaction or a redox reaction, where iron loses its electrons to oxygen and forms rust. So redox is just a way to look at reactions in purely the terms of electron transfer, electron exchange, and just in terms of the net electron changes. So what exactly does reduction on oxidation? What's the difference between reduction and oxidation? Now, you might have heard this acronym before, but it's the difference between them can be summarized to this phrase: oil rig, where oxidation is loss, reduction is gain. So oil rig. And I like to think about I like to think of it differently. I like to think of it as oxidation is like when something oxidizes, it rusts, so it loses. Reduction is the opposite. But yeah, oil rig is the best way to remember it. It's very clear what it's about. So what does loss and gain mean? It just means loss of electrons, gain of electrons. Like I said before, the iron rusting example. So the oxidation in that case would be the iron would be an oxidation being oxidized. That would be oxidation of iron. So the iron would lose its electrons, and it would be the reduction of oxygen. So that would be oxygen gaining electrons. So let's look at some examples of this, right? So we have would be like awarded just redox reaction. So chlorine gas reacts with iron 2 nitrate to produce an iron 3 compound. So we have here Cl2. I'm not gonna write states because that'll take a bit more time. Plus Fe2 plus transfers into Fe3 plus. Okay, this is really hard to write. Fe3 plus something else. Right, and let's just figure out what's the rest of the compound. So we have here Fe2 plus, right? It loses an electron to Cl. So Fe2 plus is undergoes oxidation, then loses an electron to the only other reactant, which is Cl2, in other situations we'll learn to know which reactant will react, but in this case it's the only other reactant other than a nitrate, but nitrate is already it's not part of this equation. But yeah, Fe2 plus loses an electron to Cl2 and becomes Fe3 plus. So we can assume Cl2 becomes Cl minus. And we can balance this out a bit. We have 2 here. Okay, that was a really bad 2. 2 here. Since we have 1 more here, we put 2 here, 2 here. And yeah, that would be a balanced out reaction. Now we can describe each of the reactants and products in this reaction. So they have specified names. So let's go here. So this is our reaction, right? Written out. And so this occurs in solution. So I put states aqueous, aqueous, aqueous. Gas, it's the compound formed will be dissociated because it is in solution. And we have, I guess, 6 terms to refer to these elements. So first of all, or these reagents, we have oxidizing agent or oxidizer. It can be referred to as either. But the oxidizing agent is the substance that takes the electron. It's the substance that allows oxidation to occur. So here the oxidizing agent would be Cl2, because Cl2 is the one that gains the electron. So you can write it here, Cl2. And the reducing agent is the opposite. It's the substance that gives up its electron. So it'd be, in this case, Fe2 plus. A lot of the times the oxidizing agent will be a solid metal, but in this case it's an ion, since iron has multivalency. Now it's important to specify the ion, not the element name, because of a factor that will be discussed in a second. So substance that lost electrons, that would be the reducing agent, Fe2 plus, and the substance that gained electrons would be Cl2. Now here we refer, now oxidized species, what does that mean? Now it seems like the oxidized species is a species that has been oxidized. So Fe2 plus underwent oxidation, it lost, so it was the substance that oxidized. So is Fe3 plus the oxidizing agent? No. Oxidized species? No, because when talking about this stuff, you always refer to the reactants. So the oxidized species is actually Fe2 plus. So it's the when the oxidized species refers to the species that will be oxidized. So in this case, it would be Fe2 plus. Important to note that if we refer to it as iron here, it could be confused as either Fe3 plus or Fe2 plus, which is not, which causes some confusion in terminology, so it's not good. But and the reduced species is opposite. Here would be again Cl2. Always refer to this stuff by the reactant names, never the product names. It's important to remember the reducing agent always undergoes oxidation and is the oxidized species. The oxidizing agent or the oxidizer always undergoes reduction and is the reduced species. And yeah, I think that's it. You will see some examples where there are multiple oxidizing agents, where there might be some acid H plus, and that gains electrons, and some permanganate that could gain electrons and become something different. Always refer to it by the reactant, and always refer to it by the simple rules of gain and loss. And yeah, that's it for today. And that's it for this intro.